Hi, I'm Robert, and we are group 13, and we are going to do the tank problem. So I will start. I was in charge of doing the tank setup and setting up the OD system. So the first thing we do is once we have our tank problem, we have to do a quick check to make sure we're even allowed to do it by making sure all the values entering the tank are equal to all the values exiting the tank. So really quick, tank 1 has 4 entering and 3 entering from tank 2. That's 7. There's 4 leaving, outside, and 3 entering from tank 2. So that's good. Tank 2 has 3 entering from tank 1, 2 entering from tank 3, that's 5. And tank 2 has 3 leaving into tank 1 and 2 leaving in tank 3. So that's 5. So that's good. Tank 3, 2 entering from tank 2, 1 entering from the outside source, 1 leaving outside source, and 2 going back into tank 2. So that's good. And now that we have that, we can make our ODE system, which will just be using our constants, which is the 4 times 5, and then subtracting the volume leaving tank 1, which is 4 plus 3, and then 3 entering from tank 2, which is right here. A2 is 3 receiving from tank 1 of A1, B1, the 5 leaving of tank 2, and the 2 coming in from tank 3. And then for A3, you have the 2 from tank 2 going to tank 3, the 3 leaving of tank 3 of 2 and 1, and then A3 of the 1 times 6 coming in from the outside source. So now we have our ODE system. We just make a simple matrix, which will just be using this value. So the first row will be -7v1, 2v2, 0v3. Second row will be 3v1, -5v2, and 2v3. And then 0v1, 2v2, and -3v3. And then for our B, which is over here, it's just the 2 constants, which is going to be the 4 times 5 entering from the outside source of tank 1. There's 0 for tank 2 because it's a closed system with nothing entering or leaving. And then for tank 3, it's just going to be the 1 times 6 up here, which is just 6. And then I will turn to the code to show what my partners did.
All right, I'm Emma, and I set up the Mathematica code to solve this matrix. You just want to define the volumes for the 3 tanks, find B, find not, and matrix A. We just solved for the eigensystem to find the eigenvalues, and then Tyler and Kyle will talk more about the graph solution and how they plotted this.
So after Emma was done creating the code, I started to plot it. So we used a plot function to plot the Y manual over a time of 0 to 24. We played with the time just to make sure that we were able to see when the solution hit equilibrium. We felt that a day was an adequate amount of time of showing that it was to where it needed to be. We went in, labeled the axes, and then used a legend that we have below. We used point 1, point 2, and point 3, which was the 24-hour mark to show which tank was what. Overall, we have tank 2, which was on top, tank 3, which was the second line, and tank 1 was the bottom line. After that, Kyle can go into the explanation on how we deciphered that.
So there's actually 2 ways you can look at this, at least what we found. One way is you can plug in the 24-hour mark, which is our final mark, to find out where the tanks end to figure out which tank. So for example, if you look down at Y manual of 24, the first value is about 33. That first value is tank 1, and so on and so forth. So tank 2 is almost 40, and then you got 39 for tank 3. Then you can use the eigenvalues. The largest eigenvalue, which was for tank 1. If you look at the plot, tank 1 reaches the equilibrium solution the quickest, and that's basically what we use to figure out which tanks were which.
All right, let's